Here's the formula for the number of permutations of n objects taken r at a time. It's given by n factorial divided by n minus r factorial. Let's take a look at one example. Suppose we want to find the number of permutations of 8 objects taking 3 at a time. So this will be given by 8 factorial divided by 8 minus 3 factorial. Now this can be written as 8 times 7 times 6 times 5 factorial divided by 5 factorial. Those cancel out. And this is 8 times 7 times 6. And that is 336. If you use a calculator, a TI-84, you can also get that number very easily. If you press the button Math, and then across the top you go to PRB, that's probability. So these are probability theory functions. And you go to number 2 and PR. Now, the calculator has a different syntax. So here you have to put the number n first, then the function npr, and then you put r. So it will work like this: 8, and then npr, and 3. This function, this notation, it's used in several textbooks, which goes like this: 8p3. So you type 8 and then the function and 3. More important than using the formula or the calculator is to really understand how we obtain the number of permutations. Now, here in this example, if you consider the 8 different objects and you're grabbing 3 of those objects and you're arranging them on a shelf, if those objects are books, then you can think of this diagram of slots. I like to use that. So the first slot represents the first book you put on the shelf, the second book, and the third book. You're grabbing 3 out of those 8. And there are 8 possibilities for the first book because there are 8 different objects. And then for the second book, you only have 7. And then for the third book, you have only 6. So you can quickly obtain the number of permutations by just remembering this notation or this diagram. You don't have to memorize any formula. So 8 times 7 times 6, that's exactly what you get here. And then you simply do the arithmetic there. Another example, let's say you want to find the number of permutations of 100 objects when you take 97 at a time. Now you can also apply the formula, right? The 100 factorial divided by 100 minus 97 factorial. That will give you 100 factorial divided by 3 factorial. This is a pretty large number, right? This would be 100 times 99 times 98 and so forth until you get times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. So that will give you the number of permutations. Now, if you don't remember the formula, you can still get the same thing by thinking about the boxes, right? The diagram that I just mentioned. So you have 100 objects and you're picking 97 of them, And this is permutation, so the order is important. So you're trying to arrange out of 100 books, you're picking 97, you're arranging those 97 books on the shelf. So you can think of the slots again, then you will have 97 slots, right? So here's the first slot, second slot, third, 90, then 96, then 97. So the first book, you have 100 possibilities. The second book, you have 99, 98. And this will go until you have 97 of these numbers multiplying. So it's going to end up at times 4. 100 times 99 times 98 all the way to 4. So you have 97 factors here in this multiplication. Now this seems to be complicated, but this will actually help you remember the formula. You can do a little trick here to and try to complete the factorial. What do I mean by completing the factorial? Well, you can see here that this is a multiplication that starts at 100 and then 99, 98 all the way to 4. So you can keep going here, times 3 times 2 times 1, but at the same time you divide by that because you don't want to change the value of the final answer. But why do I do this? Just to complete the factorial, so this will give me 100 factorial divided by 3 factorial. So you don't have to remember the formula for the number of permutations. You can simply recall exactly what this is, how do you find the number of permutations. And you can always remember the analogy of picking books and trying to arrange them on a shelf.